Welcome back. This is actually the second time that I ran out of time, so we're looking at the end of problem 16, which is the identifying properties of the function. We got started in the last video on this. We found the domains. We excluded some numbers in the domains. We then looked at vertical asymptotes by looking at the denominators after factoring. We found the vertical asymptotes. Now we're working on horizontal. This is where the video ended. We had a horizontal one at 0 here because the numerator is less than the denominator powers. The lead term powers are less. Now, as I said on this one, or I started to say, I'm not sure if I got cut off last time, is that the powers, since the denominator is x squared plus 4x plus 4, the powers here, x squared and x squared, are the same. That means our horizontal asymptote is dividing those two terms. So since the two terms are both x squared over x squared, they're not 3x squared over 2x squared. It's just going to be y equals 1 for a horizontal asymptote. So the horizontal asymptote here is at y equals 1. Alright, the other things that we have to do here are zeros and end behavior. So zeros, okay, zeros of the function. So that's when the function itself equals 0. So we just look at zeros as if the numerator was equal to 0. So on the top here, this one over here, the left-hand one, x plus 2 equals 0, so its 0 is at negative 2. As a 0 at negative 2. Okay? And on this one, we look at the factored form here, which is right here on the other problem, on problem number 32. So 32 has a 1x plus 1 and x plus 2 as its reduced form. That means it has a 0 at x equals negative 1. So we just take the reduced form here and we look at the numerator. So x plus 1 equals 0. So its 0 is at negative 1. So we have a negative 1, 0 there. The other one is undefined as it was reduced out. So there's the zeros of both functions, 31 and 32. Alright, now end behavior. So end behavior is based upon what the function is doing as it goes to infinity. So we're looking at when x goes to infinity, what happens? As x goes to negative infinity, what happens? Now both of these have asymptotes, or horizontal asymptotes. So that is where it's going to actually approach. So in this case, f of x is going to approach our horizontal asymptote, which is 0 here. So we're going to go to 0 on both cases on 31. And since we have a horizontal asymptote at 1 here, on the other one we're going to have the function approaching 1 in both cases. So anytime there's a horizontal asymptote, your end behavior is going to approach that horizontal asymptote. Alright? And at the vertical asymptotes, you're either going to go approach infinity or negative infinity at those places. Alright, and so that's the end of 16.